Hey students, welcome to Learn Digital. This is the second video of implementing different concepts in C++, and now you have already seen the implementation of class or creating a class in object-oriented programming, and this is the program actually. So let us go to the second part. With this same program I will make changes. So I already told you in the previous video that a class containing the data member and the member function, and creating creating objects in main and calling the member functions with the object name, and you can create any number of objects of the same class. And with that I already told you that in class the definition of member function can be done inside the class, or it can be done outside the class. So in this program we did actually inside the class. The definition we did inside the class. Here see, this is the definition of input function, this is the definition of add function, this is the definition of subtract function, and see the declaration, actually the structure of the function, user defined function or the member function, it is here in this line, and the definition is together. And this is the class definition as a whole, the starting of the class definition, and this is the ending. Inside that we define the function clearly, we can understand. Now it's time to define a function outside the class, and you have to understand that if we define outside the class the function outside the class, there is no problem. What is the benefit of that? That the definition of the class, it will make, it will be very much complex if you start defining all the functions inside the class. See, so it is better if you have many functions, and if you have big functions or large function, many with number of instructions more. So if what you can do, you can declare the functions inside the class, and you can define the function outside the class. There is an operator called scope resolution operator, which actually associate your outside function definition with the class you want to associate it with. Here this is the input function. See, I am copying this total whole definition, control C, and here I am defining, and this input function here, so no definition is required, so I'm deleting this part. But declaration, we must have the declaration. Here is the declaration, only this much. And again for this also, this is add, here we are defining, and here we will delete the definition part. Again for this we'll copy that and we'll paste outside the class, and this is the definition of that. Subtract function and definition is deleted from the class definition. Here this is the declaration of three functions, and you have to put semicolon because this is the complete statement. And then here we are going to define the function definition outside the class, and I will told you that to associate these functions with this class, the definition which is actually outside, there will be no problem if you put this thing, capital A, then scope resolution operator, this and this, and again here A, this and this, capital A, scope resolution operator. Means 2 colon actually. Now see, return type of the function, then class name, then scope resolution operator, and the function name. So when you will do 2-3 programs, it will be very much like easy for you writing these statements, and nothing to worry about that whether you can remember all the synthesis of this object-oriented programming model. It's not a big deal. When you start writing your program, it will be very easy. At the beginning you just see and write, you just take help of internet, you take help of these programs what I have already written, you take help of book, and then you start writing. Once you have written 4-5 programs or 2, then it will be very much usual for you to write the synthesis. Then at that point actually the logic will actually matter, or remembering the concept will actually matter. Synthesis will not help, bother you. If you really want to write programs only knowing the logic or your programming skill is actually enough. So see, the definitions are outside all the functions, so you can keep some functions inside the class and some functions outside the class. There is no problem. So let us compile whether this program is correct or not. Compile. Yes, there is a problem with this. What the error is that a is private, input is private. Yes, there is a problem. See what we can do here. We have to make the member function public. We have made the member function public. So like again, yes, no matching means when you are calling the function, no matching, because see, at the time of calling, what you are actually doing, you are actually giving inputs, because in the function you see you have inputs. So what you can do actually, you no need to actually write like that. What you can do, because in the input function you are taking a and b, so what we can do is a and b. No need to have this. We can have, because what we are doing actually, we are printing z here, not, yeah, we can use c, because we have a variable c in our data member section. Again, here we have this thing, and no need to have these variables here, because we already have this data members here ABC, and we are taking values through this input function, so no problem. So, and we are not sending any this one argument. So let's compile. Yes, there is a problem. Yes, it's a typing mistake. Control C, Control S, compile. Yes, there is another error. The error doesn't match with the doesn't match any in class A. In the class A, yes, in our declaration part we put this thing. So declaration, definition and call must match. Same function cannot have different architecture. See, it's like whenever you write program, it will be like there will be many error, and do not afraid if any error comes, because when you are logically correct but syntactically or some logic may be missing some time, and there is no problem. No need to be perfect at the first run or first go. It's the actual way of writing programs. When you find problem, you just correct it and again compile and run. See, now our program is correct and no problem. Let us run it. Yes, 6 and 2, the summation is 8, and subtraction should be, result should be, the subtraction should be 4. So we did some mistake here in the subtraction part. See, we again added a and b, and it should be written like result, or the result of summation. Same thing here. Let us save it, compile. Very important, whenever any change is required in the program and you made it, and so you must compile it, because otherwise the change will not be reflected in your executable program. So compilation means changing the source code into the executable code. Otherwise the previous version of your executable code will be running, and you will find you cannot figure out what is the problem. Again and again you are getting the error, so it means you are not saving and you are not compiling your code again and again. So let's run it. 7 and 2, 9 and 5. Yes, the result is 9. The summation and subtraction is 5. Yes, we did it. So in the earlier video we did the definition inside the class, and here outside the class the definition of functions. So let's go to the next section. So here we can go with our usual method, that inside the class definition, again like previously we did. Here you go and you just erase all this declaration and put your definitions and declarations together, and the scope resolution and all these things will not be here because you are inside the class. No requirement of the scope resolution operator, and you are okay with that. So let's save and compile. Let's see whether our, yes, this should not be here. So we did not delete it, so we must delete the definition which is outside, because we already copied inside the class. Here let us compile. Yes, our compilation is correct, means our program is correct. 7 and 2, 9 and 5. Yes, correct. So inside the class definition, in the same program, what we did, the outside the class definition, the function definition outside the class definition, and the function definition inside the class definition. This is the class, and we defining functions inside the class. So let us try other concepts of the same program. And we talked about inline function, so let us discuss, or let us implement this inline function here. So our inline function, so what you have to write, actually the keyword inline. If you write, the function will be inline. So what is inline? I have already discussed in the earlier videos, still I will discuss here. So let us write inline keyword in front of any function. Here any function, you write inline just before the return type, and then compile it. Okay, then run it. Okay, our program is correct. So what inline actually did, the keyword inline, and what is the actual purpose of using inline doing nothing with this code or logic of this function. Actually inline is doing something like, when you call any function, see, this is the call of the function. Actually that call is actually call from this point. Actually the compiler is going to any of the definition where the function is stored, and when you write inline, actually the code will be copied where the function is called. It's like I have to take the help of our must use this pen and paper here. See, this is a function. So this is the function definition, suppose add, and this is the definition. Here you have written some code. So when you call from main, suppose from main you are calling the function add 2, 3. So when you call it, normally what happens, actually the compiler goes from here to here, and actually in the memory what actually happens, this is your RAM, suppose, or memory, primary memory. Here is the main define, this is the main, and suppose 100 number locations, and this is actually your add elsewhere, and this is suppose 200 location. This is add, we call it function or routine or subroutine in respect of memory. Here when add is called, the compiler goes from this to the actual location, and it executes and again come back to the main. Nice, this is called execution and compilation, execution of program with functions. Here inline, when you make inline, this is inline. What actually you are making, what you are doing here, this is not going anywhere. Actually you are copying all this code somewhere. Here you are just bringing this line, this code statement, suppose 4 statements, and those 4 statements will actually come here and the compiler will not go elsewhere, it will execute here. Here means in a memory, you can say a buffer or a place where compiler can copy and paste. So what is the benefit? The overhead means the transportation cost going from here and adding or the executing this code and coming back, this cost will be minimized. This cost will not be here because you are actually bringing this code here. So this is actually all about this inline function. Inline means where in the line at the line you call the function, the code will be copied and pasted here, and you just, or the compiler will execute. So let us go to the dev C++ again. So this is called inline function. Here we'll again implement different concepts. So this second video of implementation of different concepts up to this. If you have any query regarding this any of the concepts implemented here in this step C++, you can write below in the comment section and let me know. Then I will clarify in the subsequent videos, and we'll see what to implement in the third video. So see you soon.